So we've got little tips here. Page is gonna blink. So if you want to have these, if you want to write these down, if you find these helpful, do so. I'm not gonna. I don't do notebook checks. It's your notebook to deal with. But when in doubt, when we're verifying, start from the more complicated side. We're not gonna. Oh, did she? That's okay. She just attacked her feet a little bit. I have a Roomba under there. It's just to keep my lights from going off when I'm in here by myself. She just disconnected from her dock. She's fine. So that's why I have some of the cleaner floors in the building. Is because I run a Roomba like every other day because it keeps my lights on when I'm the only one in here. Anyway, back on topic. So we're not going to work both sides at the same time, ever. You can work on both sides. There are some professors, like when you get to higher math in college, some of them will say absolutely never. Absolutely never. You work one side and one side only. I'm not super strict about it, so if we need to be able to see something, I get it, because we're still new with this. We're still learning. Just know that if you do higher things, there's some that are very strict about it. We're going to keep eyes open for those Pythagorean IDs. We're probably going to see those. We'll need to use those sometimes. Sometimes we're going to try a little substitution. Think back to like when we did U substitutions for things, those kind of guys. When in doubt, put everything into terms of sine and cosine. See if we can cancel things out. And don't give up. The verifying is the biggest don't give up of everything. Okay? Keep trying things. Don't leave stuff blank. Try things. Okay? So we're going to try a few of these. And actually, I'm going to put our Pythagorean IDs up here for a second, just because it might have been a second since we've seen these. I'm going to put them back up here. They're not different. I'm just going to write them up here so we have them if we want them again. These would be our sine squared theta plus cosine squared theta is 1. That's the one we use by far the most. By far the most. It's not the only one, but it is the one we use the most. We also have that 1 plus cotangent squared is cosecant. And then the third one is the tangent one. It's very similar. It's the 1 plus tangent squared is secant squared. So the cos go together, cosecant, cotangent. Tangent goes with secant. It feels very random. It's all based off of the sine squared, cosine squared, so you can technically get through with just that one. If you switch everything to sines and cosines, you can do everything with just sine squared, cosine squared. They might look super gross, but you can do everything with just sines and cosines. It's just longer. Okay, so being able to use all three is ideal. If you can only work with the sine squared, cosine squared, it's doable. It's just going to be longer. Okay, so we're going to practice using these. We're going to practice doing all these things. We are keeping eyes on time. Okay, cool. All right, so anyone have these ones written down? Cool. So here's our first one. We've got 1 plus the sine of x times the quantity 1 minus the sine of x. And we want to verify that that's the exact same thing as cosine squared. So we pick the more complicated side to work on. Or if they both look kind of equally complicated, go with the one that has addition or subtraction. Just because it's easier to switch those around. So we're going to look at the left side on this guy. This side, definitely more complicated than the right. Because it's easier to take more complicated and make it simple than it is to take simple and make it weird and big and complicated. So what can I do on this left-hand side to try and simplify this thing? Multiply it out. I've got 1 times 1. That gives me 1. We have our 1 times minus sine of x. We have minus sine of x. Sine of x times 1, so we get a plus sine of x. And then I get sine of x times minus sine of x, and we get minus sine squared of x. What do we notice in here? The sine of x's cancel out. These guys cancel out. So we're left with 1 minus sine squared x. Think about our Pythagorean identities. We're thinking about that. Okay, screen, let me zoom in. There we go. If we think about our sine squared theta plus cosine squared theta equals 1. If I subtract sine from both sides, we get that cosine squared theta equals 1 minus sine squared theta, right? Well, 1 minus sine squared theta is exactly what I have here. It's just 1 minus sine squared of x. So this is the exact same thing as if I had cosine squared x by that Pythagorean identity, which is exactly what we wanted this side to be, cosine squared x. My left-hand side matches my right-hand side, and we are verified. I want my left side to match the right side, and that means we're done. Okay? Questions on this one? That's all the stuff we need to do on this one. Yes, dear.
It's only going to be the identity. How going to be the 1 over CSC, 1 over...
We may have to use those. Yeah, to know the reciprocal identities, but at this point I was hoping we know this. Okay. We should hopefully know that, you know, our cosecant is the 1 over sine, and our secant is the 1 over cosine, and cotangent is 1 over tangent. Oh, speaking of. Yes, dear. Question. I will go back. Yes. Just being slightly sarcastic.
Squared would you count it right? Like if we didn't put like cos equals cos. Like on the
At this, like for previous, yes, I would count that. I was like, moving forward, I want us to make sure we're getting all the way down to where it's exactly the same left and right. Okay, but like we were still baby verifying people. We're still being new at it. We're just gonna slowly get better and better and better. Okay, and for those of us that struggle with verifying, just know you are 100% not alone. Verifying is awful. The only way it gets slightly less awful is just by practicing it. It's just one of those things. It's weird, it's awkward, you don't always know where you're headed, and that kind of doesn't change. Even when you get up into higher things, I still have to do verifying in my classes, and I don't always know where my end goal is when I'm going. You just have to kind of keep trying stuff and hope you find it. So sometimes that happens. So it's okay, we can get through it, but that's why we practice these, because once we practice it, we feel a little less headed into the darkness. We at least get a flashlight. Okay, so we're practicing, it's giving us our flashlight into the world of verifying, and it's very scary and dark. All right, so we're gonna look at cotangent squared theta times secant squared theta minus 1, and we think that that is equal to 1. So we wanna verify that. What's up?
Nothing.
Okay. What are we seeing here?
I'm seeing cotangent. Can we like subtract that from put it on the other side? And then like and then make it tangent?
I see where we're headed. We're going to do our very best not to cross equal signs. We would really, really like to not cross equal signs because then we're more into a solving aspect than a verifying aspect. But the tangent is 100% where I would love for us to go. I was like, if we do need to cross equal signs because we are 100% stuck, I get it, but that leaves the world of verifying and heads more towards solving. So, I know, that's the instinct, is to start crossing equal signs. But you actually saw the thing I was wanting us to see in here, which is this guy. Because I see a secant squared and a 1, which makes me instantly think of my Pythagorean identities. We had one that involved a secant and a 1, and that was our 1 plus tangent squared theta. That was our secant squared. Yeah. So if I subtract 1 from both sides here, because we can play around with our identities, we get tangent squared theta is the same thing as secant squared minus 1. So these guys we can move around. I'm just going to scooch this over because that was right on the edge. Oop. There we go. So in my Pythagorean identities, we can scooch these around to do what we need them to do. But we're trying not to, in our verifying problem, cross equal signs. But I can notice that secant squared minus 1 is exactly what we have here, which means I can replace this chunk with our tangent squared. So this is tangent squared theta, and we have our cotangent squared theta, and we want to see if that equals 1. I'm just going to put the equal sign. What should we do from here?
Expand too close.
Yeah, absolutely valid strategy. To put this in terms of sines and cosines, that makes it a little bit easier. For some of us, we'll also do or we would rather do the cotangent being 1 over tangent. That is another fine way to approach this. But I'm going to go with the way that we came up with, which is our cotangent. If I want to put cotangent squared in terms of sine and cosine, which one goes on top? So this is going to be cosine squared theta over sine squared theta. Means the same thing as for cotangent squared. Same guy. And then we have our tangent, which is our sine squared theta over cosine squared theta. That's a bad theta. Holy cow. There we go. Better. And then what happens here? Yeah, we've got things that cancel out. I've got sine squared over sine squared. And we've got cosine squared over cosine squared. They cancel out, which is going to leave us with what? 1. So we get 1 equals 1. So our left-hand side matches our right-hand side, and we are good. We are verified. Because my left-hand side matches my right-hand side. That was definitely meant to be the eraser, not the laser pointer. Okay. Present time. Oh, we are so good on time. We're doing great. Okay, questions on this guy? Okay, let's do another one. So this one's got a beta in it. It's just giving us a different letter. We will see all kinds of different letters. That's why I have our little list up on the top where we've got our alpha, our beta. We will sometimes see delta or gamma. Rarely are we going to use epsilon because that means a thing in calculus, but it's there sometimes. Totally fine. Yeah, I whatever our variable is, I do not care if we change it. If you want to switch it to an x, if you want to switch it to a heart, if you want to switch it to an alpha or a theta or a whatever, I don't really care. A variable is a variable. It takes a place. You could put it to a happy face emoji for all I care. I was going to say that's sometimes why we do the emoji math on challenge problem, and because it's just a variable. It just looks more fun if it's a cupcake. But the reason I don't do them on the board is because y'all have seen my airplanes. That's about as good as that gets. I was going to say, when we have dolphins, they look shockingly similar to airplanes. If they jump on a quadratic, all you do is you just, no wings, just a rudder. And it's a dolphin. I am not good at drawing. But that's okay. We don't need to be good at drawing to do this. So we've got here cosine squared of beta plus minus sine squared of beta equals 1 minus 2 sine squared beta. So first thing we got to do is figure out what the heck we want to do. My thought on this, when I'm looking at one like these, is I'm going to pick the side that has 2 different things because I can work towards making things match easier than trying to split things apart and change one into something else. So I'm going to work this side because I can try and make cosine switch into sines to do this. So I'm going to start on the left side. You do not have to. There are ways through these problems from either direction. There is not a wrong pathway through unless you give up. That's the only way to be like totally wrong on it. So we'd really like this to only have signs in it. So do we know anything about cosine squared that I could relate to things that only have signs in them?
Oh, 1 minus sine.
If we think, again, those Pythagorean identities, if we think with our sine squared theta plus cosine squared theta equals 1, I can rewrite this again as our cosine squared theta as our 1 minus our sine squared theta, right? If I replace this cosine squared beta with this guy, I'm going to get rid of the cosine and only have sines. So I'm going to, screen's being weird. I'm going to replace our cosine squared beta with 1 minus sine squared beta. That's coming from our Pythagorean ID. Then we have minus sine squared beta. That's coming from the rest of our problem. So all those bracket things are related to each other, except for, there we go. All the bracket things are related to each other. What can we do here now? Yeah, we've got some like terms. I've got minus sine squared, minus sine squared. So I have minus something, minus something. So what is this going to be? 1 minus, how many sine squareds do I have here? I have 2 sine squareds. 2 sine squared beta. And that is exactly what we wanted it to be. So sometimes we have to stop and look at them real close to be able to get there, okay? I wanted all of my cosines to turn into sines, so that's where we had to pull out that Pythagorean identity. Questions on this one? Okay, because as we go through these, we're going to start to see more and more and more things like numbers show up in problems. So we're going to have more numbers. Back to math with numbers. What? Not as many words in our math problems. It's weird. Okay, questions on this one? Okay. Now we've got tangent squared of alpha plus 4 equals secant squared of alpha plus 3. What do we see? Do we know anything about the relationship between tangent squared and secant squared? Yep, and there's any number of ways you can write that Pythagorean ID. I think I wrote it on the last page as our 1 plus tangent squared theta equals the secant squared theta. There's also places where we'll write it where it's going to be our tangent squared theta is and that is too close to the wall, so I'm going to write that again because I'm going to run out of space. Our tangent squared theta is the same thing as our secant squared minus 1. Those two things mean the same thing. We don't need to cross over. I was going to say, in our Pythagorean identities, we can use either one of these because we're just trying to make a substitution to work in here. The Pythagorean IDs are separate from it. We can manipulate those in whatever way we need to. We can cross equal signs there. It's in the verifying problem itself. We want to try very, very hard not to cross the equal sign. So I always think verifying of this is like a force field wall. We're not crossing the line. I can do whatever I want to on the left side, and I can do whatever I want to on the right-hand side, as long as I'm not changing the equation. I just want to do something over here. And you can use either one of these IDs that we wrote up at the top over here. It doesn't matter which one we do. I'm going to ask y'all to pick one. Do you guys want to replace the tangent, or do you want to replace the secant? I was going to say, I heard secant first. It's not wrong to do either one. As I said, we've worked left-hand side for all of them, so I'm going to go right-hand side on this one just because we can. There's nothing wrong with it. If you want to go through the tangent side, it should look almost identical. So I'm going to work the right-hand side just because it's excellent practice for us to see the other side. It doesn't only have to be the left-hand side we work with. So I'm going to notice up here that my secant squared alpha, I can rewrite using my Pythagorean ID up here. I know secant squared is the same thing as 1 plus tangent squared. So I can rewrite this as 1 plus tangent squared alpha, not beta, alpha. And then we have our plus 3 from the rest of this equation here. What can we do here? Add the 3 and the 1. I've got like terms. Combine my like terms of 1 and 3, and we get our tangent squared alpha plus 4. It would be almost identical on the other side because secant is, our tangent is secant squared minus 1. So we'd have a minus 1 plus the 4. We'd get our 3 over here. So either way, it's going to work the same. So it's not a super complicated one, but we are going to be working with those Pythagorean IDs a bunch. Okay. Questions on this one? We'll probably do one more. Okay, let's look at this one. It's a little bit ickier. We got sine squared of theta minus sine to the 4th of theta. And we know that equals, we want to see if that equals cosine squared theta minus cosine to the 4th of theta. In this case, both sides are kind of the same amount of grossness. So there's not one side that's grosser than the other. We're just going to pick a side and commit. And I know we see sine squared and cosine squared on here, so we're probably going to want to look at this guy at some point. Our sine squared theta plus cosine squared theta equals 1. That guy's probably going to be involved here somewhere. I'm going to work on the sine squared side just because left-hand side. I don't know. I'm just making a choice. So I'm going to work on the left-hand side. What do we notice over here that we could do? Yeah, we know that sine squared is the same thing as 1 minus cosine squared. Because I can move this guy around up here. Sine squared theta is the same thing as 1 minus cosine squared theta. So I can replace my sine squared theta with that ID. So we'll have this guy be our 1 minus cosine squared theta. What can we do with the sine to the 4th? I think I kind of see what you're thinking, because it's the same thing as if I had sine squared and we multiplied it by sine squared, right? So this thing is the same thing as if I had sine of theta squared, right? Squared. Yeah, so I can replace this sine squared with that same kind of guy, where we're going to have our 1 minus cosine squared theta minus 1 minus cosine squared theta squared. So my sine squared I can write as, or sine to the 4th, we can write as sine squared squared. I'm going to replace that theta because that sucker looks like a 6. There we go. Okay, so from here, now we can do very much like we did on the last one or on the first one where we multiply it all the way out. So we're going to have our 1 minus cosine squared theta. And we're going to need to be really careful because we're subtracting this whole thing. 1 minus cosine squared theta times itself, we're going to wind up with 1 minus cosine squared theta times minus cosine squared theta, so minus 2 cosine squared theta. I want to see where that piece comes from. Plus cosine to the 4th theta. Ooh, I heard a wood on that one. Hang on. Scooching that guy down. 1 minus cosine squared theta times 1 minus cosine squared theta. And we're going to distribute this guy. I just combined my like terms in one step here. So then what we're going to do is we need to simplify this thing. I've got this minus. We need to remember to distribute our minus sign through here. So we're going to have our 1 minus cosine squared theta minus 1 plus 2 cosine squared theta minus cosine to the 4th of theta. And what do we see here? My 1's cancel out. And then we have some like terms. I've got a minus 1 cosine squared and a 2 cosine squared. So if I have two things and I take away one thing, we're left with our 1 cosine squared theta minus our cosine to the 4th of theta. You are 3 minutes early.
Teachers at this time, all balcony seating only. Balcony
That's not us.
seating only to the auditorium quickly, balcony seating. I'll be making 2 more announcements for the rest of the auditorium. Balcony seating at this time.
Okay. He's 3 minutes early, and that's why I said this one was our last one anyway. All right, so we got to the end here. We have our cosine squared theta and our cosine to the 4th theta. What's up?
Oh, never mind. I thought you said you were gonna still go or something.
Nope, that was the end of it anyway. I was gonna say, I was just gonna put up the last page that has all the stuff on there and our information about tomorrow, because tomorrow's an e-learning day. Questions on this guy before I change the page. All right, tomorrow's an e-learning day due to parent-teacher conferences. There are videos already posted with more verifying problems. There's not additional work for you to do. There's not like any learning assignment. There's some videos that have, I think, 2 verifying in each video, so they weren't like super long. So it's not additional assignment. It's the same assignment we would have normally had. On the way in, you guys picked up the schedule for this whole chapter with all the homeworks. It should have the same problem numbers on here that it has on that thing, because I'm usually at least semi-decent at catching those. But yeah, that's kind of the vibe. When they call for we were probably in the last section that goes, we're section 4, which is the back half of the house. If you are a theater person or you know your theater dimensions, we're back house right. If you look at the auditorium, there's this is the stage. There's 3 sections in the front and there's 4 sections in the back section. We are in this one. Okay? So there's this big walkway, and this is where the doors are over here. So doors here, doors here.
Wait, are we coming back?
No, you will take your stuff with you, because honestly, we will be lucky if we release on time, let alone have time to come back here and then dismiss.
Could you get my folder from work district?
Yeah.
Because I left my review and like all that in there, and I went to it.
Yeah, let me get you.
Can I finish this on Friday?
Yes. Second. What's up?
We do play. If we want to do in-person conferences.
They just come.
They just-
I believe it starts at, it's either 2:45 or 3 is when that starts, and we'll be set up in tables in the hallway, and they'll just follow your schedule. That's not the bell for us. Hang tight. He's gonna announce.
Can I wipe my name off the board of the
Yes.
Yay!
Wipe my name on. We just go to
Alright,
the
but
class.
did you do it?
Yeah, I did.
We'll all. They will. It's not like timed or anything. It's just we're all out in tables in the hallways, and they will just go to whatever teachers they need to talk to. All right.
Yeah, I would be really scared.
Sections 1, 2, and 3.
Not us.
Sections 1, 2, and
We're
3
four.
only. Nobody else should be leaving the classroom. Sections 1, 2, 3 only.
And Matt?
Nobody
You got a
else
whole
should be
community
leaving the
watching you.
classroom. Section 1, 2, 3.
I don't know that the orchestra is going to be open because a lot of those, like the teachers are involved in the convocation, so they might be in there. So he might have locked that door.
I'll see. If I find
Usually
And so
walks
we'll be in
and he's not
section
there.
4.
Where is he? Why is he going?
He's got to get his reviews. He left it in his orchestra folder.
He's so for real. He wants to do that right now.
That's what he says. I'm gonna say, I don't know that he's gonna be able to, but he can try. All right, there we go.
That's when they try to hold those class meetings.
Uh huh.
They try to hold those class meetings. I'm just trying to get work done.